Welcome back to another exciting episode of Heavy Wireless, part of the Packet Pushers Podcast Network. I'm your host, Keith Parsons, and today we have a remarkable guest who's been making waves in the realm of industrial Wi-Fi. Prepare to be inspired as we delve into the world of robust, reliable wireless solutions that power some of the most demanding environments on the planet. Our guest today is Scott McNeil, a leading expert in industrial Wi-Fi. Scott has been at the forefront of deploying and optimizing wireless networks in challenging industrial settings for over a decade. In this episode, we'll explore Scott's journey into the world of industrial Wi-Fi, the latest advancements in the field, and practical insights for anyone looking to understand or implement wireless networks in tough environments. Whether you're a seasoned professional or just curious about how Wi-Fi works in the industrial world, this conversation is packed with valuable knowledge. So tune in, get comfortable, and get ready to elevate your understanding of industrial wireless technology. Welcome to Heavy Wireless. Let's dive into the robust world of industrial Wi-Fi with Scott McNeil. Scott, it's a pleasure to have you on the show. Thank you for joining us on Heavy Wireless. To kick things off, can you share a bit about your background and what drew you to specialize in industrial Wi-Fi?
Well, it's interesting when I look back at where I started. In my late 20s, early 30s, I went back to school and kind of retooled myself because I was a bartender and I was in sales, and I didn't want to do that for the rest of my life. So my wife encouraged me to go back to school, which I did. So I went to our local community college and went through the Cisco Academy and did the whole networking bit and really enjoyed it. And I had a few wireless classes while in school, and I really found that I had a high interest in them. When I graduated, within 2 weeks, I had a job with a local wireless outfit, a wireless integration outfit. And this was during the day when Google was really out there pushing hard with their metro area Wi-Fi and trying to light up every city for free and all this stuff. And so I was with eProach Communications for the better part of 4 years, and it was awesome. And we did I learned a lot, and we did a lot of integrations for smaller local resorts because we're in a beach community. We actually lit up our downtown segment about a square mile with metro area Wi-Fi that's sponsored by the city. And I really enjoyed that, but we started doing a lot of travel. My wife and I were trying to start a family, so I moved on from there to our local school system, worked in lower ed for a while as a network admin, and then moved
I just have to laugh. You said lower ed. I'm like, what? Oh, the opposite of higher ed.
Versus higher ed. So,
okay.
It's K-12 versus college.
Yeah, that works.
And so I was there for a while, and then got on with the actual community college that I went to, and was there for, probably 5-6 years. And that's where I really dove head deep into wireless, because at that point, all they had was a few hotspots. And I took they had at the time 3 campuses. While I was there, opened a 4th. I brought wireless to all campuses and interconnected and roaming. And they actually started reducing their computer labs because I was showing them the value of having mobile laptop cart labs that they could then use throughout. And it was an Aruba shop, so I integrated ClearPass, and we got a lot of great. I was able to get all their SSIDs down to 2. We had a guest in the school, and we did individual user experiences depending on whether you were a student, a faculty, or a standard employee. So an admin. So on the same SSID, you were getting different VLANs, different functionality, and different access. It was awesome.
That whole role-based access. Yeah.
Yes, sir. And that's actually what drew me into some of the deeper stuff was, and to this day, I still feel that Aruba has an amazing grasp on role-based access in general. But I thoroughly enjoyed that. And the problem is there was no room for growth. When you're in that kind of setting, you're there. There's not much of a chance for upward mobility. There's not much of a chance to make more money. By this point in time, my wife and I, we had our kids and everything, and we were to the point to where things were a lot more stable. And then a guy got in touch with me who, when I was in my eProach communication days, we had done point to multi-point wireless setup for them at this wastewater treatment plant at a paper mill. Well, he and I kept in touch over the years in between, and he was always kind of a networking mentor of mine. And well, he came hard at me after about 5, 6 years at the college, saying, "Hey, man, we need some more network experience on our team." And I was like, "Really?" And he was like, "Well, what?" And I was, "Well, what all you guys doing?" And that's when he started explaining to me about OT and the differences between enterprise and industrial settings when you get off of the factory floor. And I was like, "OT, what is OT?" And he's like, "Well, OT, that's operational technology. So you have information technology, which is in your offices and everywhere else. As soon as you get out of those carpeted spaces and you're down on the factory floor, that's OT. That's controls. That's networks. That's server infrastructure. But it's not in the pretty happy places that you're normally used to going. They're down in the dirty operational centers." And I was like, "Well, that sounds really interesting." And he's like, on top of that, once you get good at it, you start traveling and you go to these places and help them develop it, because there's a lot of industrial sites that can't afford their own OT staff full time. So they use integrators like us to upgrade their systems and get them moving along. Meanwhile, the controls guys are doing all the control stuff. And then, we're supporting on the back end, making sure all the controls are communicating with all their endpoints like they need to. Because over the years, when it comes to industrial controls, a lot of it has moved from direct serial connections over solid core copper, like, ThickNet, if you want to think back coax days, very similar, to Ethernet over IP, Ethernet IP, and just different industrial protocols have moved to Ethernet. So they're encapsulating their protocol in an Ethernet packet and kicking it across Cat 5e at the time. And I was like, that's fascinating. Let's do this. And so I got on with GPA at that point, Global Process Automation, and they are industrial integrators. And it was amazing. And as I started learning the differences, because in OT, we use a lot of the same equipment that IT uses, but it may not look the same. So when you're looking at your
physically they look different, or they work differently?
They actually work the same, but physically they work different. No, they look different. So you have a standard rack switch, 1U mounts into a rack. Well, that's not what we're using out in the field. We're using a hardened industrial switch that mounts on what's called DIN rail. And that switch is not powered. You don't just go plug it into a wall. It uses 24-volt DC. So it has a different power structure to it. And so it's these cool little cubes that have switch ports on them. But when you log into them, it's that same CLI interface you're used to in a rack mount switch. The functionality is the same as that rack mount switch. It's just a different form factor. And once you kind of get past that and realize, oh, it's the same thing, then it's all good. But on top of that, there's different rules of the road in OT versus IT. So I don't know if you're familiar with the CIA triad, the confidentiality, integrity, and availability, right? With confidentiality being top dog, security, then integrity, and then availability, right? Well, with OT, you got to rotate that, because availability is top. Because if your data is not available, systems don't run. If systems don't run, the manufacturing process does not happen. And despite what anybody says, industry is all about that productivity. You stop production, there's a problem, and someone's getting yelled at. So that is your top dog there, followed up by data integrity, right? So your data has to get there reliably, and it has to be complete. Security is a complete, afterthought.
Nice to have.
It's a nice to have if you can afford it, and you have the swag to be able to bring that in and bolt it on top. But if it's not getting there reliably, and it's not all together as the data should be, then what's the point? Because your system's not running, right?
Well, it sounds like in OT, historically it was cable driven. And one of the things I like to say is, if it doesn't move, it should be wired. So how many of these are mobile devices that need that wireless access?
It's interesting when you look at it, because that is still the case. If it's a fixed position, if you can wire it, wire it. But the other aspect of that you have to look at is the cost of that wiring and cabling. So if I put in a new piece of equipment down at the other end of my facility, and it's going to cost me $75,000 to get conduit and cabling put in place to communicate with that end device, or I can spend 10K and get a reliable wireless connection that's going to give me my, 5 nines of uptime. What is the plant manager going to look at when it comes time to cost for that project? Now, there is an understanding that, you have to proof of concept that out and make sure it's going to meet the requirements of the application. But if you're going to save $100,000 and it's not going to affect your productivity overall, then why wouldn't you? Now, for the longest time, wireless was a big, no, we're not going to do that in production. But over time, as generations have kind of moved out and new generations have come in, the attitudes have been changing, and wireless has become, over probably the past 10, 15 years, a little more prevalent in dirty industry than it used to be. Like I said, 20, 30 years ago, it was unheard of to have any of this out there on the factory floor, with the exception of some SCADA sensors way out in the field. And those were real basic analog signals, but they needed it because they had these small little outposts miles away that they needed to pull data from, right? And that was usually like a 900 megahertz transmission, had one of your old school TV look antennas on top to communicate back to the control system so they could read analog information off of pumps or electricity.
You just used another term, SCADA.
Yeah. And you know what? The sad thing is I can never remember what SCADA stands for off the top of my head, because I don't deal with a lot of SCADA systems.
But they've been around for a long time.
It has been sensory control. And I don't remember the full acronym on it.
We'll look that up and add in the show notes.
Yeah, we'll look it up and add it. So normally the systems that I'm in and around are DCS, which are distributive control systems, or PLCs, which are programmable logic controllers. And it's two different schools of thought that accomplish the same thing: the impact of a real world device from a logical standpoint. So a DCS or a PLC have various inputs called IO, input output, and then the majority of that IO is all hardwired in. And then it takes that information and then sends out configuration changes to these devices out on the field. So it may be starting a conveyor or stopping a conveyor, maybe something that simple. Or it could be something as complex as keeping a chemical reaction going, because it's a chemical plant. They're trying to produce a specific product, and it takes the injection of multiple chemicals at specific times, at specific heats. So it can be as simple as an on and off, or it can be as complex as keeping that chemical reaction going. And so the communication needs for these things, you can see, are critical, right? If it needs information input from these sensors, that input is critical for its maintaining process, right? This is where people were, I won't say scared, but skeptical of having wireless be able to bring that data in. But then over time, they actually created very specific protocols for this. And, when you look back, WirelessHART was created. That was the first wireless industrial protocol that was out there, right? Followed up shortly thereafter by ISA 100. And these were 802.15.4 based protocols that were then manipulated to provide the stability and integrity that those communications needed. So now all of a sudden, this opens up great communication options to smaller facilities that may not have had the money to be able to expand, because now let's say, we can put that in, we can add WirelessHART to it. We don't have to add data cabling configuration to that. We can save $200,000 on this project and still have that reliable data coming in that we can then use in our controllers to work on that process.
You use the word reliable. Normally we think in the OSI model, reliability is up TCP versus UDP. You're referring to this reliable PHY MAC layer.
Two.
Yeah.
Correct. Correct. I'm referring at layer two at the MAC layer, and which that's kind of where 802.15.4 gives the handoff because it's not a layer three protocol; it's all layer two. It lets you develop your layer three however you want to, uh, but it's how it handles physically the radio communication. It's spread spectrum, it's channel blacklisting, it's various other communication, I guess structures would be the way to say that. It's got a lot of little pieces, parts that help keep that communication structure hopping across its spectrum and that data continuously going in reliably. At the same time, running CRCs in the background to make sure the validity of that data is complete all the way through.
Well, a lot of our listeners understand 802.11, how it's CSMA-CA, listen before talk, and when things get crowded, you might not get the frame delivered when you think it's going to be delivered. What do these IoT protocols do to help? I mean, are they in that same listen and wait, or is there some time-based control? How do they manage making sure that frame gets delivered on time accurately?
You get pretty deep into it, and essentially comes down to its frequency hopping and how it controls that. And it's sensing the whole time, but it's using multiple communication channels to do that sensing for them. And Bluetooth is kind of a prime example, and it's an easy example to use. With Bluetooth, you have 3 advertisement channels, right? Well, those 3 advertisement channels are communicating with their client saying, hey, look, we're going to communicate across these channels in this order, right? We're going to hop across it and we're going to barrage you with this amount of data. And that client's going to say, okay, you know what? Thanks for the heads up. I'm going to listen in this order so I can get all of that data. And I will check my CRCs. And if they're a little off, I'm going to send you, hey, we need to retransmit. And then the transmitters be like, hey, you know what? We got that CRC error. We're going to resend it, and we're going to block that channel that we originally sent it on because we realize that one's not working too well. So it's all instant, how fast it's all happening because it's within 10 milliseconds or less of the communication factor there. And it's just insane how it adapts so quickly when it's seeing, the random CRC error here and there is not enough to trigger a channel blacklist. But when it starts getting multiples, and it'll just start taking those channels out of this kind of pseudo-random rotation.
What kind of data rates are we talking about here? I can't imagine these need to be, megabits worth of data.
No, it's all like 250K or less. We're talking serial data. In the industrial world, it's low bandwidth. It's all, like I said, 250K or less. And if you go and look on your wired network and you're looking at the throughput of these things, you're not going to see it go over a meg. And if you do, that's not the actual industrial protocol itself. That's some add-on to the packets on top of that.
Hello, podcast listener. If you've ever wondered why no one's talking about IPv6, we've got good news. IPv6 Buzz is a twice-monthly podcast dedicated to this essential and sometimes perplexing protocol. IPv6 Buzz will equip you with everything you need to know about planning, deploying, and operating a V6 network. Hosts Ed Horley, Tom Coffeen, and Scott Hogue literally wrote the books on IPv6 architecture, deployment, and security. They share their knowledge and speak with other experts on topics including unique local addressing, DHCP v6, SLAC, firewalling in IPv6, and much, much more. They also answer listener questions, so if you've got a burning IPv6 issue, you may be able to get it on a show. So plug into the future with IPv6 Buzz. Find it on packetpushers.net or listen wherever you get your podcasts.
Well, what's the infrastructure like? In Wi-Fi, we have an access point, and then we have client devices, and we have, 2, 4, 1, 6, and 11. What would an industrial setup look like? Do you have a central access point, or do they mesh? What kind of different protocols are you using?
It depends on the application, right? So if you have mobile devices moving around on the floor, either warehouse or any number of different reasons, you can have, and they don't have their own wireless capability, you can actually put an industrial wireless client on them, which is great because then you get more control over roaming, because you can, with most of these wireless clients, you can go in and say, hey, look, we know we are only using in this deployment channels 44 and 60 and 20 megahertz and 5 gig. let's not scan any other channels. We're going to take that out of your roaming scan because there's only two APs that you can roam to. One's on this channel, one's on that channel. So we're going to take channel scanning completely out of the picture for roaming, and that alone speed things up. And then on top of that, on some models, you can restrict it down to MAC address as well. So you can only roam, you can only scan these specific channels, and you're only going to roam to one of these two MAC addresses. So you've already gotten rid of a ton of issues that you would normally have to deal with a client roaming around for regular data that you no longer have to deal with. And that cuts your roaming time down substantially and makes it a lot more stable. In some models, you could actually go ahead and set what your thresholds are. So once you reach TX, RX values, we want you to go ahead and transition to that other radio. So you can get even further controls over that. ProSoft is an industrial manufacturer of radios, and they actually have, they spell all that out. So you can really get granular control over your device roaming. And that's not something you can
on
get
Wi-Fi,
with,
not on WirelessHART. This would be a Wi-Fi kind of solution. Yeah.
On Wi-Fi.
I'm just thinking of describe the device. It has an Ethernet port you plug into the industrial device, and then it's just going to be a wireless bridge and turn into Ethernet.
Correct. And that's the thing is, and they'll have multiple modes. So let's use Phoenix Contact, for example, on their WLAN 1100 series. If your main AP is a Phoenix AP, and then your client radio is also a Phoenix device, then you don't have to really do any sort of special configuration. When you'll link them up in the Phoenix mode, because it'll have multiple client modes that you can set. You set it up in its Phoenix mode, and it will pass transparently all data, both layer 2 and layer 3. Okay? It's Phoenix to Phoenix device. You'll be able to pass industrial protocols at layer 2 with no problem. You'll be able to pass IP protocols at layer 3, no problem. It does not care. And it'll be completely transparent to the data. But if you have a Cisco wireless infrastructure, but you still need those same devices talking wirelessly back, well, that's fine. You take that Phoenix radio, you put it in one of its alternate modes of operation. If it's only going to be one single device behind it, then you can put it into let's see, what is it? STB, I think, single transparent bridge is what they call it. And that one device, it will give you, and it's compatible with just about every manufacturer out there. I've actually tested it against Cisco and Aruba APs here in my lab. And it will pass all of your layer 3 and layer 2 traffic. Again, industrial protocols will flow right through it because it's a single client. You can even mask the MAC address of that client if you wanted to. But if you have multiple devices behind that, well, there's a different mode you put that in. So then so if you have an object that has 3 or 4 devices on it that you need IP connectivity to, you can put one of these clients on there, put it in that multi-mode, and it will be a transparent bridge for all those devices there, but it will only do it on a layer 3 level because it's not going back to another Phoenix device. It's going back to a Cisco, an Aruba, a Ruckus, or whatever. So the standards apparently for that are a little different when it's multiple devices behind a client bridge versus a single device behind a client bridge on your settings. Now, the magic secret sauce to what makes that work, I'm not really privy to that. But it's interesting because, you have a ton of flexibility with one little radio.
Well, you've been, this last one with Phoenix you're talking about, it's using Wi-Fi chips, Wi-Fi protocol, and they have this special Phoenix sauce. Is your logic as you think through a situation where would you use WirelessHART as the technology rather than this Wi-Fi technology you mentioned? Okay,
WirelessHART is controls specific. So, it's not a Wi-Fi technology. It's 802.15.4. It is doing it's an IoT technology if you want to think about it. It's really the first IIoT that was ever put out there. So WirelessHART was IIoT before IIoT was IIoT. And then, like I said, it's directly connecting to the control system on a layer 2 fashion from radio to radio. Whereas it's not going through your
when you
your
just said
standard
radio to
OSI
radio,
model.
did you mean like a wireless point-to-point bridge, or is it still point-to-multipoint?
Well, when I say regular radio, I'm referring to 802.11 versus 802.15.4.
Yeah. So in 15.4, do you have the controller talking to all devices on the other end at the same time on one radio, or is there multiple radios?
There's multiple radios, and generally there's multiple radios in a mesh configuration. And it's usually kind of in a self-healing mesh, and it's all connecting back to its WirelessHART gateway that is passing that serial data back to your DCS or your PLC.
You've used a lot of new terms for us to learn, so I appreciate that. Where might someone go to learn about this OT and IoT and IIoT?
For me, it was a lot of hands-on experience, and I was fortunate enough to have a mentor who brought me in, and I was able to shadow for a number of months before I was cut loose on my own to really learn about all this stuff hands-on. Let's see, you got the CWNP IoT track does touch on a fair amount of this. It doesn't get too depth on the industrial side, but the concepts still hold true when you're looking at things like Bluetooth, which is pretty heavy in there. And Bluetooth is used universally. That is used in IT. That is used in OT. Even though it's a 2.4 frequency technology, as opposed to 900 megahertz or something that's a little more conducive to your steel and metal and whatnot everywhere.
Factory environment, yeah.
Right. Bluetooth is still completely viable in those because of its adaptive frequency hopping. It's amazing how AFH is so resilient even in 2.4, but that kind of gets me on a whole other time. And I even lost where I was going with that.
Well, no, totally fine. This week, in fact, just a couple of days ago, you were in Raleigh doing at the WICO meeting, and you gave a little demo, a little hands-on demo. Can you spend a minute and talk about that?
That was so much fun. I had been talking with Ali Muhammad for quite some time about the whole WICO thing, and then I was like, "Hey, man, we hardly ever have these events here in North Carolina. Let's try one here." And he got in touch with Dawn Douglas, and she took it and ran with it. And next thing I know, we've got this event scheduled, and I'm like, "Sweet, I want to present something." And we're trying to figure out what to do. And I was like, "Hey, would you be opposed to me doing a hands-on lab versus just a standard presentation?"
And who hates hands-on labs? They're fantastic.
That was my opinion, know, but I didn't know what he may had in his mind as far as how he wanted to run it. And he was all for it. He thought it would be great. And so I immediately started digging into my lab gear, trying to find out what I had the most of, what way would be a really good way to present this. And next thing I know, I've got all my lab gear, and I was kind of short on a couple radios that I thought I would need. I reached out to Phoenix Contact, and they were like, "You know what? This is a great opportunity. I'm going to send you 2 more radios." And they did, and I was able to put together this awesome connectivity lab using 8 of their industrial radios. And they had sampled DIN rail boards that I could mount everything to. It was fantastic. And so what I was able to do in that lab is I gave a short presentation to kind of introduce what OT was and let them know what we were going to be using. And then I said, "All right, look, this is what we're going to do. You guys are going to hardwire a 24-volt power supply. And then you're going to hardwire power from that power supply to my access point. But I did reassure them that I'm going to check your wiring before you actually plug the power in, because I don't want you frying one of my radios." And then once you've done that and we've got lights, we have a configuration lab that we're going to go through, because Group A1, you've got to make your radio talk to Group A2's radio. And Group B1, you've got to make your radio talk to Group B2's radio. And you're not going to successfully complete this lab until you can ping all radios and then ping your opposing partner across them. And so it was a lot of fun. And so they got, hands-on experience with wiring up a 24-volt power supply and then connecting that power to an industrial AP, having them locked in on DIN rails so they can see the different mounting capabilities. And then going in and doing the manual configuration of these devices, because that's another big difference between most industrial radios and enterprise radios is they're not controller based. And so you're having to go in and configure radios individually. Now, there are some manufacturers have software to help you push out base configs. And if you're good at scripting, you can actually plug a bunch in and do that stuff. But traditionally, you're configuring one radio at a time. And it was great because you got to go in there and they got to see all these configuration options. And we get halfway through and I stop everybody because I'm keeping everybody kind of going at the same pace. And I'm like, look, you're looking at this. One of your team is an AP, your other team is a client. You're seeing all these client options. What are these client options and what are their use cases? And I was able to walk them through the use cases for these different client options. Because one of the client options is actually a NAT box. It can do network address translation for a device behind it. So if you get a device that from some manufacturer and you're putting it into your production environment, but you can't change the address on that because the manufacturer who made that device says, no, you can't do that.
No one ever does that.
Oh, it's it's insane how common that is in the industrial world. But now you can say, okay, well, I'm going to slap this AP on there and I'm going to NAT it to our network range to what we want it at. Or to take it one step further, you could actually, instead of doing a one-to-one NAT, you could set it up for NAT overload or port address translation. They call it masquerading in the Linux universe. Up to 32 clients behind it, so it could port address translate up to 32 other devices behind it. So it has all these multitudes of different functionalities to fit multiple use cases, yet you're standardizing on one device.
Well, Scott, very, very happy to have you on the show. Before we end today, give us like a 30-second ad for your podcast.
Oh, I noticed out there that there really wasn't any kind of vendor neutral resources for wireless in the industrial universe. So I was like, I started my blog and then I really, to be honest with you, I started listening to CTS, Roel and Francois, and I binge listened to a ton of their episodes and I loved getting that content audibly. And that really kind of inspired me. And I was like, you know what? I'm going to bite the bullet. I'm going to do it. And I started my own podcast, the Industrial Wi-Fi Shop. And it's the industrialwifishop.com. And I'm up to 6 episodes. Well, 7 really, because 5 was a 2-parter. And I've been getting a lot of great reviews. I've been covering a lot of different content, from doing assessments in the industrial universe to doing specialized episodes on where I talk about WirelessHART and ISA 100. I just did an episode about Bluetooth. We did a design roundtable where I had a bunch of other guys on the show with me, and it was great. And the conversation flowed, and we talked about all the tools that we use in that environment versus what we typically use in the enterprise world. And it's really taken off, and I've gotten a lot of positive feedback. I'm on Spotify and Apple Podcasts, and it's just been a lot of fun. I really enjoy it. Well,
thanks again for having you come on. There's an entire world of industrial Wi-Fi out there and OT. If you're not currently involved, you might want to think about expanding your career a little bit and looking into some of these other issues. Hopefully, Scott will get you and a OT deep dive at one of the upcoming WLPCs. That would be great fun.
That's on the radar. That's on the radar.
Sounds good. Well, thanks for your time today, Scott.
No, thank you for having me. I really appreciate it.
You've been listening to another episode of Heavy Wireless, a Packet Pushers podcast. If you're interested in all things wireless, come back and listen to future episodes of Heavy Wireless. My name's Keith Parsons, and I'm glad you were here listening.